The Webb telescope uncovers the farthest star in cosmic history. The universe is vast, filled with mysteries that have intrigued humanity for centuries. With the advent of increasingly sophisticated telescopes, we've been able to peer deeper into space and uncover secrets that were once unimaginable. One of the most groundbreaking revelations came from the James Webb Space Telescope, JWST, the most powerful space observatory ever built. Launched in December 2021, the Webb telescope has already started rewriting our understanding of the universe. Its most recent discovery, a distant star that could be the farthest ever detected in cosmic history, has left astronomers awestruck and has opened up new frontiers in astrophysics and cosmology. The mission of the James Webb Space Telescope. Before delving into the historic discovery of the farthest star, it's essential to understand the mission and capabilities of the James Webb Space Telescope. Named after James E. Webb, the NASA administrator who played a significant role in the Apollo missions, the telescope represents the pinnacle of human ingenuity. Its primary objective is to observe the universe in infrared wavelengths, which allows it to peer through cosmic dust and gases, unveiling celestial bodies and structures that were previously hidden from view. The Webb telescope operates from a position known as the second Lagrange point, L2, a stable location in space about 1.5 million kilometers, nearly a million miles, from Earth. This position allows it to observe the universe without interference from Earth's atmosphere or the sun's light. One of Webb's defining features is its 6.5-meter wide golden mirror, which provides unprecedented sensitivity and resolution. This allows it to detect incredibly faint objects billions of light-years away. Webb's instruments are designed to explore several key aspects of the universe, including the formation of stars and galaxies, the atmospheres of exoplanets, and the birth of planetary systems. However, one of its most exciting capabilities is its ability to look back in time. Since light takes time to travel across the vast expanses of space, when Webb looks at distant objects, it's actually looking at them as they were billions of years ago. This makes Webb a time machine, capable of revealing the early stages of the universe, including the formation of the first stars and galaxies. The discovery of the farthest star, Earendel. In 2022, just a few months after the telescope became operational, Webb detected the light of a star that existed when the universe was only about 900 million years old. This star, named Earendel, is now the farthest known star ever observed, located a staggering 28 billion light-years away. The discovery of Earendel, whose name means morning star or dawn in Old English, is particularly significant because it provides a unique window into the very early universe, a time when stars were just beginning to form. Prior to Webb's discovery, the most distant star ever detected was also found by the Hubble Space Telescope in 2016. Named Icarus, this star existed about 9.4 billion years ago. Earendel, however, predates Icarus by an additional 4 billion years, providing a much clearer glimpse into the universe's infancy. The star was detected through a phenomenon known as gravitational lensing. This effect, predicted by Einstein's theory of general relativity, occurs when a massive object, such as a galaxy or galaxy cluster, bends and magnifies the light of objects behind it. In Earendel's case, a galaxy cluster called WHL 0137-08 acted as a gravitational lens, amplifying the light of the star by more than 1,000 times, making it visible to Webb. Without this gravitational lensing, detecting a star like Earendel at such a vast distance would have been impossible, even with the Webb telescope. The light from such a distant and faint object would be too weak to be observed directly. However, with the galaxy cluster acting as a cosmic magnifying glass, Webb was able to detect the star and study its properties in unprecedented detail. Why Earendel's discovery is so important. The discovery of Earendel has profound implications for our understanding of the universe. By studying the light from this star, astronomers can gain insights into the conditions that existed in the early universe. During this epoch, known as the epoch of reionization, the first galaxies and stars were forming, and the universe was transitioning from a dark, opaque state to one filled with light. Understanding this period is critical for piecing together the history of cosmic evolution. Earendel is also likely one of the first generations of stars, potentially a population 3 star. Population 3 stars are hypothetical, extremely massive stars thought to have been composed almost entirely of hydrogen and helium, the only elements produced in the Big Bang. These stars are believed to have played a crucial role in producing the heavier elements necessary for the formation of planets and life. However, no direct evidence of population 3 stars has been found, until possibly now. If Earendel is indeed a population 3 star, it could help answer some of the most fundamental questions in astrophysics, such as how the first stars formed and how they contributed to the chemical enrichment of the universe. These stars would have been short-lived, burning through their fuel quickly and ending their lives in massive supernova explosions. The remnants of these explosions would have seeded the universe with elements like carbon, oxygen, and iron, which are essential for the formation of planets and life as we know it. The technology behind Webb's success. Detecting a star as distant and faint as Earendel required the cutting-edge technology that the Webb telescope brings to the table. Webb's ability to observe in the infrared spectrum is particularly important for detecting objects in the early universe. As the universe expands, the light from distant objects is stretched, shifting it from the visible spectrum into the infrared. This process, known as redshift, means that the farther away an object is, the more its light has been redshifted. Webb is perfectly suited to observe these redshifted objects, allowing it to see farther into the past than any previous telescope. In addition to its infrared capabilities, Webb's large mirror and advanced instruments allow it to gather much more light than the Hubble Space Telescope, enabling it to detect extremely faint objects. The telescope's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, are particularly well suited for studying distant stars like Earendel. NIRCam can capture detailed images of distant galaxies and stars, while MIRI is capable of analyzing the chemical composition of these objects by studying the infrared light they emit. Webb's ability to perform spectroscopy is another critical tool in the study of distant stars. Spectroscopy involves breaking down light into its constituent wavelengths, allowing scientists to determine the chemical composition, temperature, and other properties of a star. By studying Earendel's light spectrum, astronomers can determine whether it is truly a population 3 star or if it belongs to a later generation. What comes next? The discovery of Earendel is just the beginning. The Webb telescope has the potential to uncover even more distant stars and galaxies, shedding light on the earliest stages of the universe. In the coming years, astronomers will continue to study Earendel in greater detail, hoping to confirm whether it is a population 3 star and to learn more about the environment in which it formed. Webb will also continue its search for other ancient stars and galaxies, helping to fill in the gaps in our understanding of cosmic history. By studying these early objects, scientists hope to answer some of the most profound questions in cosmology. How did the first stars form? What was the universe like in its infancy? How did the first galaxies evolve into the massive structures we see today? Additionally, Webb's discoveries could have implications beyond the realm of astrophysics. By understanding how the first stars and galaxies formed, we may gain insights into the conditions that made life possible in the universe. The heavy elements produced by the first stars are necessary for the formation of planets, and studying their origins could help us understand how life came to exist on Earth and whether it might exist elsewhere in the cosmos. Conclusion. The James Webb Space Telescope has already revolutionized our understanding of the universe in its short time in operation, and the discovery of the farthest star, Earendel, marks a milestone in astronomy. By observing this ancient star, we are peering back in time to a period when the universe was in its infancy, just beginning to emerge from the cosmic dark ages. As Webb continues to explore the depths of space, it will undoubtedly uncover even more wonders, helping us to unravel the mysteries of the cosmos and our place within it. The discovery of Earendel is a reminder of the incredible progress we have made in our quest to understand the universe, and of the countless discoveries that still await us.